Okay, hi everyone. I'm Krista from Zandwijk and I'm a PhD candidate at the Eindhoven University of Technology. And today I will explain you how we can actually develop a data space that fits the needs of the industry stakeholders and also improves building data management. So as many of you already know, the industry has been dealing with this fragmentation of information for quite a long time. And it's actually partly due to the fact that we use centralized information systems to manage our data. And in centralized information systems, the data owners are actually reliant on a third-party authority that manages the data exchange, but that often also owns the server. And this actually means that the data owners are reliant on this third-party entity. And the centralized information systems are also often not providing information exchange between these different systems, which actually leads to fragmentation of information. And the European Union actually also recognizes this issue, and they state that this actually is a missed opportunity for economic growth and innovation rates, and therefore in their European strategy they actually focus on the creation of common European data spaces. And a data space is actually an example of a decentralized information system. And in this decentralized information system, information is actually exchanged peer-to-peer, so the third-party authority is removed from the equation. And the data is shared based on shared policies and rules. And this makes the data owner, this gives the data owner actually more control over their own data. And recently there have been several data spaces already developed in the different kinds of industries, such as the health industry, the energy industry, but also the mobility industry. So when I started this research, there were actually developments in 9 sectors, and now it's already like 14, so this is actually growing. But the construction industry is not really in the picture yet. And the data space research in our industry is actually mainly focused on back-end development. So most research is focused on interoperability and security, and also machine readability and decentralized data storage. But the front end is actually often neglected. So we don't really understand yet how end users would use the data space and how the data space would actually help to improve data exchange within project, but also between projects across the entire building lifecycle, but in the future maybe also between building life cycles. And that's why I focus on the data space development from the end user point of view. So how can we develop a data space that actually meets the needs of the end user and that improves building lifecycle data exchange? And to achieve this, I use the system engineering methodology. And that means that I first identified the user needs and the system requirements. Then I made a conceptual system design using unified modeling language diagrams. Then I developed the prototype using test-driven development. And finally, I validated the system by comparing the prototype with the initial requirements that I defined. And I also used a real-life project from an engineering consultancy to check if the system would work with this data. And I organized a workshop in which stakeholders from the industry participated, and I provided them with a survey, and after that survey we had an open discussion in which we discussed the advantages and disadvantages of the system and also possible improvement points. And I don't have time to explain everything, but for the system requirements, it was really important that the data space would meet the regulations of the industry, and a regulation that was, regulations and standards, sorry. And a standard that was mentioned to be very important was the ISO 9650. So for the stakeholders mentioned that clients of the construction project find it really important that the companies work with this standard. And in the ISO 9650, they actually distinguish different statuses of information containers. So information can either be work in progress, shared, published, or archived. And I use this structure to actually make the conceptual system diagram. So I made several diagrams, such as the use class diagram you see here. But I will not explain this entire diagram, but the most important thing to notice here is that the data space contains files, and each files have metadata. And a very important metadata information is the file status. And depending on that file status, the file actually appears in one of the sub data spaces. So actually you see like a nested structure here, and depending on the person's role, the file is visible in the different data spaces. So if it's like a work in progress, the file will only appear in the personal data space of the data owner. So a file, oh yeah, and this actually follows the ISO standard, as I already explained. So each file is owned by a person, and a person can also have a role, and depending on that role, the person has access to different data spaces. But in essence, it's actually one data space, but it depends on the file status and the user role, if a user can actually see the file or not. So to develop the prototype, I compared several system architectures, but the two most important ones are the IDSM RAM4 and the Merge stack. So the Merge stack is a combination of Mongo, Express, React, and Node.js. But I finally chose to use the Merge stack, and then I used MongoDB for centralized metadata management, while the actual file was actually stored in a decentralized way, which was based on the IDSM RAM4. And for the middleware, I chose to use the JSON Web Token for now, but that's a major improvement point for future research, but I will come back to that. And then I, of course, developed the code. So in my conference paper, I have this figure to explain the entire code, which I will not do now. But I wanted to let you know that this figure exists, and my code is also on my GitHub. But I actually wanted to explain today what actually happens with the data when a user interacts with the data space. So first, the user needs to upload their data, and when they do this, they actually need to fill in a lot of metadata, so to which building the data is related to which project, and also what the file is about. And then this metadata will be stored in the MongoDB data space, while the actual file is for now saved in a personal data space folder in the backend of the code. So this is like the improvement point that I was talking about. So now it's actually still centralized in the backend of my prototype, but in the future this should actually be stored on different servers that are dedicated to the user. And then the file becomes visible in the personal data space. So here you can see that the file status is actually private, so it's only visible in the personal data space. But when the user changes the file status to, for example, public, it will appear in the public data space, which is in this case the building data space. So in that case, the metadata will be updated in the MongoDB database, and the data is visible in the building data space. And now any user that has an account on the data space can actually view this file. So all files can be viewed in the browser, but I also included an IFC viewer, which makes it possible to view multiple IFC files at the same time. And this is actually a video of the working prototype. I also have a very elaborate video on my GitHub account if you're interested to see more. But here on the left side you see the navigation bar, which makes it possible to navigate to the different data spaces. And this is the data upload page, where you need to fill in the metadata and upload the file. And then here you can see the personal data space, where you can also edit the metadata if you're, for example, made a mistake. And then the other data spaces actually have the same user interface, so they all look the same, but they just have different information depending on your own role and if you're registered to the team or project. And here you can see the IFC viewer. It's sometimes a little bit slow because it was not the focus of the project. Yeah. Okay, and then for validation, the users really liked that there was like one centralized user interface that could be used to access data from different projects, because at this moment they are often reliant on multiple systems. And they also like the alignment with the ISO 9650, because that makes it really clear for them, because they are so familiar with this standard, who actually has access to which data, which increased the transparency and the data access. And then improvements points was the advanced search capability. So now it's only possible to search in the metadata and not in the file itself, which make you very reliant on how well you fill in the metadata. And then there's also this issue of version control. So it's actually now possible to download all the information. So after like someone revoked access rights, and if someone else already downloaded the data, there might be this possibility of different versions, and it's also of course not very safe, so we should also improve the safety of the system. And the stakeholders also highlighted the integration with already existing systems. So with this research, I actually hope to contribute to the front-end development part, and we actually saw that we need this nested structure of the data space that makes it possible to give different people access rights based on their roles. And it was really important to comply with the standards and regulations, and I used the ISO 9650 for that. And this actually increased the data sovereignty and transparency for the users, so they actually know who can access or who can see their data and who can't. So the future research should mainly focus on improving the backend, and I would recommend to you to look at the IDSM RAM 5 for that. So now they actually improve their data space architecture and their security mechanism, of course. So that was my presentation.